Hello class 12 science. Yesterday we started the topic disaccharides, and we came to know that disaccharides are that carbohydrates which on hydrolysis will give you two monosaccharides. It can be same or different. Okay, and the two monosaccharides are linked together. The two monosaccharides are linked or joined together by an oxide linkage formed by the loss of water molecule. Such a linkage between the two monosaccharide units to oxygen atom is called a glycosidic linkage. So while formation of disaccharides, the two monosaccharides, it can be same or different, they lose a molecule of water and they form a oxide linkage between the two molecules, and this oxide linkage between two monosaccharide units through oxygen atom, we call it as glycosidic linkage. We'll see the example what is called glycosidic linkage. Examples of disaccharide is sucrose. So sucrose on hydrolysis will give you equimolar mixture of D-glucose and D-fructose. So when you hydrolyze sucrose, that is C12H22O11, when hydrolyzed, it will give you D-glucose C6H12O6 and D-fructose C6H12O6. Okay, so these two monosaccharides are held together by glycosidic linkage between carbon number 1 of alpha glucose and C2 of beta fructose. Since the reducing group of glucose and fructose are involved in glycosidic bond formation, sucrose is a non-reducing sugar. This we have already seen, that sucrose is a non-reducing sugar, and it cannot reduce tolerance reagent and filling solution. That's why it is a non-reducing sugar. Now, the formation of sucrose, you can see over here, this is the alpha D glucose, the cyclic structure of alpha D glucose. Now, in a similar way as we have seen for glucose, if you try to draw the structure for fructose, cyclic fructose structure, it will be only a 5-membered ring, and that will be look like a furan. Okay, this is pyranose structure, this is furan having a 5-membered ring. Now in this, at carbon number 2 of fructose and carbon number 1 of glucose, we have got OH over here and we have got OH over here. So that OH, the two OH will remove a molecule of water and oxygen link is formed between these two carbon atom. Okay, now this linkage, this oxide linkage between the two molecules is known as glycosidic linkage. Okay, so sucrose is a dextrorotatory, but after hydrolysis gives dextrorotatory glucose and liberatory fructose. Since the liberation of fructose is more than dextrorotation of glucose, the mixture is liberatory. Thus, hydrolysis of sucrose brings about a change in the sign of rotation from dextro to levo, and the product is named as invert sugar. This dextro and liberatory comes from the optical activity. Okay, if it is plus, that means the plane polarized light will rotate towards the right, so it will have plus or dextrorotatory, and if it rotates towards left, then it is liberotatory, or we denote it by negative sign. Okay, and because the sucrose after hydrolysis, there is a change in the rotation from dextro to levo. Because of that, it is known as a invert sugar. We also call it as invert sugar. That is all about sucrose. Next we have got maltose. Maltose on hydrolysis will give you two molecules of same monosaccharide, that is alpha D glucose and alpha D glucose. Now in this, how the oxide linkage or how the glycosidic linkage is formed. Another disaccharide maltose is composed of two alpha D glucose units in which carbon number 1 of one glucose 1 is linked to C4 of another glucose unit 2. The free aldehyde group can be produced as C1 of second glucose in solution, and it shows reducing properties, so it is a reducing sugar. Okay, now over here what we have done is we have taken the alpha D glucose, two molecules. Now at carbon number 1 of one alpha D glucose and carbon number 4 of another molecule of alpha D glucose, we have got OH group, OH. Now from that two OH, H2O will be removed as a water molecule and oxygen will be linked between these two. So this will be a glycosidic linkage between this in this disaccharide. So we need to know that maltose on hydrolysis will give you two molecules of alpha D glucose. Okay. Next, the third disaccharide we have got is lactose. That we it is very commonly known as milk sugar, since this disaccharide is found in milk. It is composed of beta D galactose and beta D glucose. The linkage is between C1 of galactose, that is carbon number 1 of galactose, and C4 of glucose. Hence, it is also a reducing sugar. Now, in this, there is a on hydrolysis of lactose, it will give you beta D galactose. Galactose is also a isomer of glucose. Say for example, we have got fructose and glucose, the isomers, functional isomers. So similarly, galactose is also of the same kind. Okay, it's another form of isomers. So in beta D galactose at carbon number 1 and at carbon number 4, okay, of beta D glucose, it removes a molecule of water and they will form a glycosidic linkage in this way. Okay, so here also what you need to remember is on hydrolysis of lactose, what are the two monosaccharides that is produced, that is beta D galactose and beta D glucose. Fine. Now today's assignment number 5. Question number 1, define monosaccharides, give 2 examples. Question number 2, what is the glycosidic linkage? Question number 3, write the hydrolysis product of the following disaccharides. So you need to write down what will be hydrolyzed products of sucrose, lactose and maltose. And question number 4, what is an invert sugar? Complete this assignment and send it in my mail.